I've run the program again. I just want to point something out here. If you notice, sometimes it takes, for example, where's a good example? Here, it took 128 million to do 496, but only 126 million to do 497. So in that, between 496 and 497, it actually took less time to do 497 than 496. Now why is that? Well, in this program we're measuring the actual time. Now, because this is a multitasking operating system, it's not just running our Java program, it's doing lots of other things at the same time. So sometimes, because we're measuring the elapsed time, not in this case we're not measuring the exact time that that just for this program to run, it's the time that the elapsed time. So the computer may have been doing other things, which is why it took longer. Why this isn't always just increasing as you'd expect. So that's an interesting thing. There's a way around that which we will look at later. But now, so what would be nice would be if we could plot. If we could plot this as a graph. So on the x-axis we'd have the numbers like 479, 480, 481, 482. And on the y-axis we would have these numbers here. So well, there's a very nice program which allows us to do that, called GNU Plot. And so what we do is the first thing we need to do is save the output of this program to a file. Now the easiest way in a Unix operating system to do that is just to redirect the output to a file called, let's call it silly. So now the program is running, but instead of everything going onto the screen, the output is being saved into a file called silly. So that's taking a bit of time. We'll wait for that to finish. So it's going around that loop 590 0 to 499 times. Wait for that to finish, and when it does, I will show you how. There, it's finished now. So now I'll run GNU Plot, and if I say plot silly, it gives me the output. So this means what does it mean? It means 2 times 10 to the 7, 1.2 times 10 to the 8, etc. So notice that we get a straight line. So what does that mean? It means that, what does it mean? Is that surprising? Well, what it's saying is if to execute do something once, and to execute do something 10 times takes 10 times as long as executing it once. To execute do something 100 times takes 100 times that it would to execute it once. So it's not really surprising that we get a straight line when we plot this graph. Now GNU Plot is a very useful thing for drawing graphs, and in future lectures I'll show you more what other interesting things you can do with GNU Plot.